In this lesson, we're gonna talk about congruent triangles. Let's first analyze what this section is about. For the relevant concept, we'll discuss what congruent polygons are, and then I'm gonna introduce a new theorem that the congruent polygons have congruent angles in each corresponding part. Okay, number 1 through 3 in the practice worksheet is about finding the angle. Then you are given the two congruent polygons. And then number 4 through 7, you should find the size and angles by reorienting the polygons and then match the corresponding parts and then list the size and angles. And finally, number 8 through 10, you have to state the pairs of figures are congruent. So the answer should be yes or no, and then you have to explain why. Well, let's first start with congruent. What does congruent mean? So congruent figures have same size and same shape. You can reorient this by sliding or turning or flipping. So if you look at the figure on this side, you can slide it like from this direction to that direction. Or you can flip it as if I have a meter here, or as if I have an axis, and then you can rotate 180 degrees. It's like popping out to our face, and then it's gonna go back into the face of the page. So that will be the flipping. And then you can also reorient the polygon by turning it. You can rotate it. So congruent polygons have congruent but also corresponding parts. So if you look at this figure, this will be flipping transformation where angle B and angle Q are congruent, angle C and angle R are congruent. Remember, they have the same magnitude of the angles, and also they have the same magnitude of the size. So for example, the segment BC is congruent with segment QR. As you can see, the X and Y are also corresponding to each other, and that means the angle Y and angle X must be congruent as well. Angle A and angle P are congruent. Angle A and the segment AC is congruent with segment RP. Here's a theorem, and let's break this down. First, okay, let me highlight this. I'm gonna start with green color. If two angles of one triangle are congruent, so two angles of one triangle, we're talking about two angles of the first triangle here, and that means if you are congruent, then you put the same mark here. Okay, so angle A and angle D are congruent, meaning they have the same angle size. So it's talking about the second polygon, two angles of another triangle, meaning D and E. They are congruent. And the third angles are congruent. In other words, angle C and angle F must be congruent because, okay, you remember that the sum of the interior angles of a triangle is 180. So if you subtract A and B, you're supposed to get the angle of C. But because we know D and E are also same angles or congruent angles with A and B, so you're gonna end up getting the same angle between C and F. Okay, let's analyze number 3 in the worksheet. So direction said each pair of polygon is congruent. Find the measure of the numbered angles. Okay, our goal is finding the angles given the congruent polygons. So number 3, we have to find measure angle 5, 6, 7, 8. First, let's identify what kind of orientation this is. You can see that there is a flip through this axis. So this will be flip. And I see A and F go together, B and G go together, Y and E go together, and X and D go together. 6 and 8 looks like right angles, and that goes perfectly with x and y. Okay, so let's write that down. Measure angle A. And I'll start with the number 5. So angle B is congruent with measure angle G in the second figure. On the first figure, measure angle X is congruent with measure of angle D. Measure angle A is congruent with measure angle F, and this would be congruent with measure angle 7, measure angle 6, and finally the measure angle Y and E are congruent with measure angle 8. Okay, we are given that B is 140. So you go up here, this is 140. By substitution, and measure angle 5 has to be 140. If you know measure angle 6 and 8 are right angles with a right angle mark, you know they are 90 degrees based on the definition of a right angle. And measure angle 7, all you gotta do is subtract from 360, knowing that the sum of interior angles of a quadrilateral is 360. So 360 minus 140 plus 90. So you just have to subtract all three given sides, and you will end up 40 degrees. And that's how you answer this problem. Now let's go to number 4. The direction is, again, you're given the congruent polygon, and this time it's a triangle. And we have to list sides that are corresponding. So let's look at number 4. 3 pairs of congruent sides. Okay. One easy way to orient this second figure is you see that A and C looks really similar to the size of S and J. So in that case, you can flip the figure as if this is something fixed. You can rotate it via or with respect to segment SJ. And I'm supposed to see D about here. You're going to notice that T and D are very corresponding, and then S, C and J are corresponding, and A and S are very corresponding. So let's write that down. 3 pairs of congruent sides. So we're not concerned with angles in this problem, just a side. So I see earlier that AC, segment AC, is congruent with the segment SJ. And then I declare that AT, segment AT, is congruent with segment SD. And finally, the segment CT is congruent with segment JD. And that's the answer. You're more than welcome to say CA is congruent with JS, and so on. Let's look at number 7. Again, we are given the congruent polygon. This time it's a quadrilateral, meaning it has 4 sides. And we have to list the angle, the corresponding angle this time instead of sides. So here we go. This one is probably easier to see because angle X and angle K, or angle X and Y and the LK are they look very 90 degrees, the right angle. And then the longest side, it would be XW or WX in the first polygon. In the second polygon, the longest side looks like a JK. So what we can do is rotate this about or turn it like 80 degrees clockwise for our first figure. Then I can redraw and then label the vertices. And it's much easier to answer it this way. Okay, so it's angle, remember, so angle Z, here Z go with M, angle W go with angle J, measure of angle X is congruent with measure of angle K, and measure of angle Z is congruent with measure of angle L. Okay. Number 9, this will be our last problem. We have to state whether the pairs of figures are congruent, and then we have to explain. Again, we're given two polygons, and an angle is given. Now, we don't know if it's really congruent or not, so we have to, if it's yes, then we have to justify. If no, we still have to justify no. So here is a problem. So at a first glance, it looks congruent, but don't let that fool you, because you will see that these figures, these polygons are not congruent. First of all, you are given that angle RSQ and angle TSV are congruent based on the vertical angle theorem. VST. Okay, that means the third side must be congruent, and that is true, because some of the interior angles of a triangle must add up to 180. However, we're not given the sides are equal. So for example, we do not know whether this side and this side are congruent. Had it been that case, then we know it's congruent, but because it's not, I can exaggerate this similar figure. For example, what if I keep the same degrees of angles in both figures? It's not perfect, but you get my idea. So in other words, I still have 95, 95. And then here is an angle R and an angle V. So in other words, this looks much larger, even though it's same shape, than the triangle QRS. So this is no, because at least a pair of corresponding congruent sides are not given. It is similar, but not necessarily. Not necessarily congruent. Okay, that's it guys. Thanks for watching. See you next time.